All right, so we are going to talk about the inverse trigonometric functions and right triangles. So let's go back to college algebra for just a second. If you recall, if we had f of x is equal to x plus 3 over 2, that we would, to find the inverse, f of x became y, and then we would swap the x and the y. It's all about y in the inverse. And so we'd get x is equal to y plus 3 over 2. Multiply both sides by 2. We end up with 2x is equal to y plus 3. Subtract 3 from both sides. And we end up with 2x minus 3 is equal to y. And this became the f inverse of 2x of this would be equal to 2x minus 3. And we knew that up here we were adding and dividing, and down here we were multiplying and subtracting. Well, the same kind of stuff happens. If you remember from college algebra, the domain and range would kind of switch. The domain became the range, and the range became the domain. Well, the same thing's going to happen in trig functions. So if we look at the domain of our functions, the sign is from negative pi over 2 to pi over 2 for the function of sign, but the inverse sign is from negative 1 to 1, which is the same thing as the range on the regular sign function, and the range is the same as it was for the domain. So those are going to switch just like we've seen before in college algebra. So the sine theta, remember, is equal to y, where theta is in the angle and y is the value. The sine inverse of y is equal to theta, where y is the value and sine is the angle. So basically what happens is it kind of flips around. So we can actually find the value of our angle then by actually knowing what the value is. So these two are basically flipping around. We will restrict the domain of the sine functions to angles between those. With this domain, the sine function attains each of the values in the interval from negative 1 to 1. There's exactly once, and so it's 1 to 1, as are the cosine and tangent functions with their restricted functions. So since the domain is restricted, the cosine domain is restricted from 0 to pi, and tangent is from negative pi over 2 to pi over 2 as well. So on these restricted domains, we define an inverse for each function by the definition of inverse functions. So the sine inverse of x is equal to y, so that means sine y is equal to x. And these are not like, these are x and y values, not like how we've been doing our trig functions with x's and y's, which basically they are because they're still x and y values. So as the sine inverse of x is equal to y, cosine inverse of x is equal to y, so the cosine of y would be equal to x. This is just kind of flipping them around, and same thing would happen with the tangent. So this is a summary of the domain and ranges of inverse trig functions. So here you can see the domain, and you can see the range. I don't know why that's not spaced over there. And you can see it again here and there as well. And we will use these to solve angles in a right triangle. All right, so let's go work some problems that will help us see clearly what we are doing with these sine inverses. So we want to evaluate sine inverse of square root of 3 over 2. So basically what we want to do is we want to find the angle. This is the value, so what is our angle? And remember that angle is between that negative pi over 2 to pi over 2. Well, if we look at this, we can find from our trig functions on our unit circle So if we go look for the sine value, square root of 3 over 2, where does that land us in quadrant 1? We're looking for the y value. That's going to be up here, the square root of 3 over 2. So that sine inverse is going to be equal to pi over 3, or 60 degrees, depending on which mode you're in. So if we're looking for the exact value, we can say that the sine inverse of the square root of 3 over 2 would be equal to pi over 3. That's using our unit circle. We could also use our calculator and find that the sine inverse of square root of 3 over 2 is equal to 60 degrees. And this would be in degree mode. So let's go pull this up on our calculator. So sine inverse is going to be right here. We are in degree mode. So if we do second sine inverse, and our value was square root of 3, so second square root of 3 divided by 2, it gets us our 60 degrees. Now, if we change it to radians, then we can do second sine inverse, second square root of 3, divided by 2. Always make sure you get out of the radical before you put the divide. And then if I try to do that, so on my calculator it's giving me the decimal. I actually have the button that'll change it to a fraction, so I can still get the pi over 3. So, but that's where you also just need to know your unit circle. I think I've said that consistently enough. You really need to know that stuff. So you can get both of them when it is one of our parts from our unit circle. Now on the next one, it is not. So we're going to find an approximate value. For the domain the sine inverse of 0.71. So we're going to use our calculator. We want to be in radian mode because that's not a degree there. We're looking for a value. So we're not looking for the angle in degrees. We're going to use a radian mode. All right, so we're looking for the second sine inverse. Second sine inverse. And then 0.71. And we end up with 0.78. We're going to go to 2 decimal places, so that'll get us approximately 0.79. And again, we were in radian modes. All right, let's do another one. Let's do sine inverse of 2. So sine inverse of 2. And we get a domain error. So why is that? Well, remember that our domain is from -1 to 1. So we can't go outside of that value. So it's -1 to 1. So this is going to get you a domain error because you're outside of it. We're only doing the ones that we have the restrictions on. All right, let's go do a cosine. So if we do the cosine inverse of 1/2, we might know this from our unit circle already. So let's clear that out. We have second cosine inverse of 1 divided by 2. We'll get that, and I can do the double arrow button on mine and get that it's pi over 3. So there we're getting those values. Remember, our domain in cosine is following what we talked about. So it will also have a -1 to 1, and then the range is 0 to pi. So we are good on that one. And hopefully you'll recognize if I was finding the cosine of pi over 3, it's going to be 1/2. So this is our angle now, and that is the value of the angle. So we're going to use these skills to do some more problems. So we are going to find the angle of theta. Now, one of the questions that you might wonder is, why do we use the inverse function? It's because we can use the inverse trig functions to solve for angles in a right triangle. So we want to find the angle theta. And we've got a triangle here. I'm going to draw it the other way this time. We've got a right triangle with a side of 10, a hypotenuse of 50, and we want to know what our theta is. So we're going to use the skills that we've learned on our inverse trig here. So theta is going to be, we need to figure out what we can use with. We have an opposite side and we have the hypotenuse. So with opposite and hypotenuse, sine would be our function to use. So sine theta is equal to the opposite over the hypotenuse, things you need to know. And so it's going to be equal to 10 over 50, which we can reduce down to 1/5. Well, that doesn't tell me what the angle is. 1/5 is not one of the things that we know from our unit circle. But I can find theta by taking the sine inverse of the 1/5 of the value to get my angle. All right, so we're in radians. So second sine inverse of 1 divided by 5. Let's see, and we want, that would be our radian. We actually want the degree mode because we want to find the degree of theta. So I'm in radians, so that gets me one value, but I actually want to be in degree because I want to find the degree of the angle. All right, so second sine inverse of 1 divided by 5, because that 0.20 doesn't really tell me anything as far as a radian mode. It's not like a pi over 3 or something. So I need to do a degree. And so we'll end up with 11.53 degrees. One of the other things you can think about with this, so which should I be in? An angle of 0.20 is not a very big angle. 0.20 doesn't get us very far. So it's not even a half of a thing. So that tells you you're probably in the wrong mode and you want to be at 11.53 instead. Alrighty. So degree mode would be what we want to do. The next thing we're going to do is we're going to, we did a tree in the last section. We're going to do a building this time. So we're going to determine the angle that's created. So we've got a word problem here. So a 40-foot ladder leans against a building. If the base of the ladder is 6 feet from the base of the building, what is the angle formed by the ladder in the building? All right, so we're going to draw us a building here. It is not a beautiful building, but it is still a building, and we're going to put some windows in it so it looks something like a building. And we're going to have a ladder between, and I don't know exactly where the ladder is hidden, but I'm just going to make me a triangle. It doesn't say, it just says the angle formed by the ladder and the building. All right, so we are told that our ladder is 6 feet from the base of the building, and it is a 40-foot ladder. And we want to find the angle from the base the angle formed from the ladder in the building. So it's not here. If they were looking for the base and the building and the ground, this should be a 90-degree angle because we're assuming that the building is upright. It's not the Leaning Tower of Pisa. If we were looking for the angle of elevation of the ladder from here up, then we would be looking at here. But we want the angle between the ladder and the building. So read your problems carefully. We got to find this angle right here. So that's the theta we're looking for. All right. We have two values. We have this one and this one. This theta, this is opposite from theta, and that's our hypotenuse. So we can use our sine function. Our sine theta would be equal to the opposite over the hypotenuse, which would be 6 divided by 40. And you can reduce it or not. It doesn't matter because you're going to get the same answer. If you can see that they're both even, you could take it down to 3 over 20. But you could also do it 6 over 40. It doesn't really matter. So now we can take the sine inverse of 3 over 20. And we want to be in degree mode. So second sine inverse of 3 divided by 20, and we'll get an angle of 8.6 degrees. So degree mode for this because you're going to want the degree of it. So this, you're starting to see a little bit more of those applications of trig in measuring things.